learn polar and non-polar covalent compounds. Well, today I am going to explain you about polar covalent compounds and non-polar covalent compounds. Alright, of course you could see here I have already written the difference between polar and non-polar covalent compounds. Okay guys, shall we get started? So let's discuss polar and non-polar covalent compounds. Student, basically we can differentiate them in terms of 4 points. Okay, here we have 4 points. Let's get going. The first point says that uneven distribution of charges can be positive charge or delta positive and delta negative. However, we have for non-polar compounds the even distribution of charges, we may get it negative values. Alright, second point says that electronegativity difference must be from 0.5 to 1.8 or 1.9 as well to be considered. Alright, however, for non-polar covalent compound, the electronegative difference should be 0 or it should be less than 0.5. Let's get going with third points. So, even the polar covalent compound depends on the dipole moments. So basically, dipole moment will be not equal to 0 for polar covalent compounds. What is dipole moments? It's basically the separation of positive and negative charge in the compounds. Alright, however, for non-polar compound, dipole moment will be 0. Okay, the last point is asymmetrical structure shows polar nature. However, symmetrical structure shows non-polar nature. What is the meaning of asymmetrical and symmetrical? Symmetrical structure, basically we have a geometry, right? Like tetrahedral or triagonal planar or linear, something like that. So it's pretty close or relevant to the symmetrical structure, or we call simply geometry of the compound. Alright, so that is pretty clear. Now there are some examples. Here we have HCl, hydrochloric acid, and hydrogen chloride, sulfur dioxide, KCl, H2O, and NH3. Okay, NH3 are actually the polar covalent compounds. However, non-polar covalent compounds are H2Cl2, CO2, PCl5, and CH4. So let me explain the first one, the distribution of the charges. Okay, how the distribution of charge can be made. For example, let's say here we have hydrochloric acid. Hydrochloric acid or HCl is bonded by a single covalent compound. So HCl is bonded with single covalent bond. So in fact, you know that chlorine is more electronegative element. However, hydrogen is less electronegative element. Therefore, chlorine will attract electron towards itself and it becomes like the negative charge. And as the electron has been taken from the hydrogen, so it will lose electron, so it will be written as delta positive charge. So this is the way we write positive negative. This is called positive and negative. So it is called uneven distributions. However, even distribution means, like for example, here we have hydrogen gas. Hydrogen made by a single covalent bond, right? So here also the same charge, of course we have here positive charge, here also positive charge. That means there is no at all attractions, there is similar charge only. Or if you take the example Cl and Cl also bonded covalently, single covalent bond. So here we will get just negative and negative. How about the electronegativity difference? How about the electronegativity difference? Now if you find the electronegativity difference of HCl, okay, so hydrogen chloride. So which is more electronegativity? Which is more electronegative element? You should subtract from that. So we know in fact the electronegativity value for chlorine is 3 and hydrogen is 2.1. Okay? Now we subtract from more electronegative value to less electronegative value. So 3 minus 2.1. So it comes out to be 0.9. Okay, the difference is getting 0.9. That means it lies between 0.5 to 1.8. So it is a polar covalent compound. HCl is a polar covalent compound. However, if you take Cl means chlorine gas. So Cl and Cl. There are two Cl. So V1 Cl electronegative value is 3 minus 3. So I am getting 0. That means if you find the electronegative difference is 0 or below 0.5, then this compound is said to be non-polar covalent compounds. Okay, so how about other compounds like sulfur dioxide compounds? Can I erase this? So basically it depends on the dipole moment and structure also. Let me do the example of sulfur dioxide, guys. Sulfur is a central atoms. Here one oxygens, here one oxygens. Alright, so we have in fact sulfur is atomic number 60, right? So electron structure 2, 8, 6. It has 6 valence electrons. 4 has been utilized, 2 are unbonded, so this is for lone pair electrons. Lone pair is there. So here whenever there is a lone pair, okay, because the polar covalent compound depends on lone pair also. Therefore you can say here dipole moment will be not equal to 0. Okay, some charge separation will be there. Therefore here the sulfur dioxide is a polar covalent compound. How about, let me take examples of, this should be carbon tetrachloride. Carbon tetrachloride. Okay, now let me take example of this. Carbon is your central atom. There are one chlorine here, one chlorine here, okay, and then here one chlorine, and there is one chlorine. So this structure, central atom is carbon, right? And here we have 4 chlorines. In fact, this structure is known as tetrahedral structure. Tetrahedral structure. Because of the tetrahedral structure, its geometry is tetrahedral, so its dipole moment will be equal to 0. Hence, it will be considered as a non-polar covalent compounds. I hope it is very clear for you. Now, let me tell you how the PCl3 is considered to be polar covalent compounds. So, in fact, we know that phosphorus, the central atoms, it has how many electrons in the outer shell? So, it has around 5 electrons in the outer shell. So 3 electron has been used for bonding, right? So it is one chlorine, this is another chlorine, so this is another chlorine. That means there is one lone pair. So I can just modify the diagram in this way. Phosphorus, chlorine here, one chlorine here, one chlorine is here. Okay, so there is still one lone pair. Hence here dipole moment is not going to be 0. So always remember, if there is lone pair compound, central atom of this covalent compound, then it's going to be polar covalent compounds. Okay? How about carbon dioxide gas? Carbon dioxide gas is a polar or non-polar? Obviously I have written here non-polar, it's going to be a non-polar compound. So if I draw the structure for it, so carbon is a central atom, here oxygen, here oxygen. So what is the structure it is? Straight line, right? So it is known as linear. This structure is said to be linear structure. Okay? So because of the linear geometrical structure or geometry of this carbon dioxide is linear, so here dipole moment will be is equal to 0. The charge will cancel each other. Here how much force is exerted that side, same force will be exerted. Therefore the charge will be equal to 0. Or dipole moment will be equal to 0, they will cancel each other out. Okay, let me just take example of methane, CH4. CH4 same things, one carbon, here hydrogen, here hydrogen, here hydrogen, and here hydrogen. So this structure also looks like tetrahedral structure. This is known as tetrahedral structure. So geometry of methane is tetrahedral, hence this compound considered to be non-polar covalent compound. So just remember, polar covalent compound dissolve polar compounds only. Non-polar can dissolve non-polar. There is the biggest enemy between water and oil. So water is a polar covalent compound, right? However, oil is not polar. So oil is a non-polar covalent compound. So they are actually enemy. Water and oil is enemy. Why? because in water oil cannot dissolve. Okay, therefore oil floats on the water. So oil is a non-polar substance, however water is a polar covalent compound. Okay, this is the basic things you have to remember. Okay, I think the polar and non-polar compound is pretty clear for you. Okay, what's your problems? How to find difference? Did you get it? This is water. So water electronegative difference. How do we find? No, you should not add this two. Okay, how to find? Let me tell you. For water, H2O is there, right? So always while finding the difference, electronegative difference, always you have to take which is more electronegative element. So here oxygen electronegative value is around 3.4 and hydrogen electronegative value is 2. How much? 2.1 around. Okay, so now from more electronegative element to less electronegative element you have to subtract. So here, don't take these two. Okay, here 2 hydrogens, but we don't use substrate. Just take the electronegative value for hydrogen. Don't multiply this two. Okay, that's sometimes you people are doing like this. Don't do like that. Just subtract as it is. So it will be coming out to be 1.3. That means its range from 0.5 to 1.3, right? 1.8, right? 1.3 is actually lies between 0.5 to 1.8. Therefore, H2O is a polar covalent compound. Did you find carbon dioxide or CCl4? CCl4? Okay, CCl4, carbon tetrachloride. So first, you find out the carbon electronegative value from the data booklet. Data booklet, if you find, so it's around, I think, 2.5 and chlorine is around 3. So always remember, don't include this subscript. Okay, just take 1 chlorine. So more electronegative element to the less. So 3 minus 2.5. So you are going to get 0.5. 0.5, right? Electronegativity difference be 0 or below 0.5 is said to be non-polar covalent compound. Therefore, CCl4 also non-polar covalent compound. This values, few numbers you have to remember. However, it will be given in the data booklet in the exams. Okay, so not worry for the electronegativity value. Okay, I think that's clear. Is it clear? Okay, thank you.